Welcome, everyone. Great to see you. Great to see familiar names, familiar faces, faces I haven't seen just yet. Welcome, welcome. Hello and welcome. We are all entering the space for our first session in the science of how students learn. Good to see everyone. Welcome. Awesome. Thank you again for deciding to embark on this journey for our science, the University Practicum on the science of how students learn. My name is Veronica Womack, and I'm the Associate Director of High Impact Teaching at the Searle Center for Advancing Learning and Teaching here at Northwestern. And I am so excited to welcome you to our first online synchronous session for this year's University Practicum on the science of how students learn. We're going to be talking about deepening connections, but I actually wanted to begin by just orienting you a bit to what you can expect for the next few weeks and few sessions. So in our university practicum this year, we have featured a presentation from Dr. Mesmin Destin, and at this point, he talked about focusing on understanding and amplifying students' motivation. And then for our upcoming sessions, they will be interactive and as well as our learning labs, and they will focus on timely topics. You'll notice that each of our online synchronous sessions will feature real world examples from university teaching award winners. And we also have a component this year of individualized consultations. If you're interested in exploring and adapting emerging strategies to diverse instructional contexts, and our colleague Un Sandoval Lee, as well as other educational developers at the Searle Center are excited to provide those individualized consultations for you if you are interested. So we do have a few learning outcomes for our program. Each of the each of our synchronous sessions and learning labs are associated with at least two of the program learning outcomes. A commonality across all of the sessions is that by participating in the sessions, you will be able to understand evidence-based teaching and key aspects of the science of learning. And you'll also notice that each of the live offerings will model the practices of universal design for learning, student success, and instructor vitality. So, as I mentioned, today's session is going to focus on deepening connections. And the connections that we're speaking about specifically are the connections between new and prior knowledge for your students. So how can we deepen and really enrich the connections across these sources of knowledge? Okay. And I'm not alone. I mentioned that we will be featuring University Teaching Award winners in our online synchronous sessions. And this session is going to feature Dr. Michael Horn. Michael, would you like to share a bit about yourself?
Hey everyone, I'm so happy to see so many people here today. Yeah, my name is Mike, and I'm a professor in computer science and learning sciences in the School of Education here at Northwestern.
Awesome, awesome. So we're going to be hearing examples of how Michael has brought some of these practices into his computer science courses. And again, since these are interactive sessions, we will be opening the floor for things that you have tried or that you might be thinking about in your various instructional contexts. All right. So, we always want to invite you to engage in this program in a way that allows you to really center a beginner's mind. And by that, we really mean having a sense of curiosity about the content that we'll be sharing. We also invite you to participate in ways that challenge and encourage our individual and collective growth in knowledge and skills. So by participating today, it does count towards earning a digital badge to reflect your commitment to developing knowledge and skills across around the science of how students learn. And also please look out for this program being turned into an open educational resource. It usually is available at about the summer point, and for that reason, we will be recording today's live offering. Okay. So you'll notice that at the beginning of all of our online sessions, we will focus on or present our participation guidelines. These guidelines are also featured on our Canvas page. And for today's session on deepening connections, we really want to hone in on the idea of committing to curiosity over certainty, and also identifying your learning edges and pushing them. So the learning edges meaning what you think you already kind of know about this content and seeing if we can expand from there. And I wanted to ground our work also in a few of the principles from the Northwestern Principles of Inclusive Teaching. And those specific principles are Principle 3, offer varied ways for students to demonstrate their learning and knowledge, as well as Principle 5, cultivate a welcoming and inclusive course climate. And again, our learning outcome for today's session will hone in on having the ability to explore strategies to cultivate learning environments that deepen student connections between new and prior knowledge. All right, so we got all of the business affairs out of the way. I have a question. In looking at this image, what do you notice and what do you wonder about? So just take a moment to take in this image and ask yourself those questions. What do you notice and what are you wondering about? Hmm. Taking it in. All right, who's ready for the reveal? What is this? What are we seeing right now? Well, it is actually, and even if you all wanted to jot down in the chat what you think you're seeing, that might be fun too. Lots of colors, ooh, nodes, networks, connections. Okay, this is great. All right, I think we're ready for the reveal. Potential patterns, paint splatter, light. Okay, the reveal is that it's a rainbow. Now, what is a rainbow? Did I just make up that word? Not exactly. So this is actually a genetic cell labeling technique in which individual neurons in the brain can be distinguished from neighboring neurons using fluorescent proteins. And so this rainbow actually shows the cellular structure of a rodent's hippocampus. And that's the region of the brain involved in learning, memory, and sensory integration. All of these are functions that are relevant to today's topic on deepening connections. Okay, so thank you for getting started with me in that way. And so in today's session, we'll have opportunities to reflect on current practices on deepening connections with your students. We'll also focus on connecting to prior knowledge, on how connecting to prior knowledge boosts learning. We'll talk about how predicting can be used as a method to correct inaccurate knowledge. And throughout those three phases, we'll also hear from Mike Horn, our Distinguished Fellow and University Teaching Award winner, about how he has applied some of these methods to his teaching context. So back to being interactive. Okay. I want to ask if you can recall a time when you noticed the students' understanding of a subject matter deepening. And as you think about this time, imagine or notice, what's coming up for you, what's coming to mind about your actions, the students' actions, the course design, the environment that kind of make you interpret or get a sense that the students' understanding of the subject matter was deepening. And as I have on our slide, please feel free to come off of mute, share in the chat. We'll be here in this reflection mode for a bit. And I'm going to be observing the chat as well. Okay. Oh, okay. Thank you. Seeing the aha moment when the students ask for clarification. So even being positioned to ask for clarification means that there's this desire to better understand, to deepen connections. Okay. Okay. And we have another comment about seeing this occur during office hours. Nice. Yeah. Students ask questions in class and requesting explanations there. Mhm. Noticing the iterative assignments and showcasing how noticing that students are improving through those iterative assignments. Oh, and for Maurice, we're seeing some nonverbal cues, smiles, eyes kind of widening. Yeah, offering original ideas of the application during class discussions. Yeah. And even if you all want to kind of sit with like, how does that feel as an instructor to see that aha moment happen where the connection is obviously deepening for the students? Yeah. Nice. Well, thank you all for thinking and sharing a bit. I did, just in case anyone wanted to come off of mute, we have space for that as well. But what's being shared in the chat, these are really good. If you all want to do a bit of a virtual gallery walk, just to see what is coming up for us as instructors here. All right. Well, let's continue forward to getting down to the science, right, of why deepening connections, or why we should deepen connections for our students. So, a book which is commonly known is called How Learning Works. It's written by Suzanne Ambrose and others. She highlights numerous research studies that showcase that students learn more readily when they can connect what they are learning to what they already know. And so the first study I want to talk about is a research conducted by Coley and Healy in 2007. And so this study showed that college students who were presented with unfamiliar facts about well-known individuals demonstrated twice the capacity to learn and retain those facts as students who were presented with the same number of facts about unfamiliar individuals. Okay, so that's showcasing how activating prior knowledge of a topic can help students integrate new information. All right, and next up, I want to talk about a research that suggests that asking students questions specifically designed to trigger recall can help them use prior knowledge to aid the integration and retention of new information. So, for example, Martin and Presley asked Canadian adults to read about events that had occurred in various Canadian provinces. So prior to any instructional intervention, the researchers found that study participants often failed to use their relevant prior knowledge to logically situate events in the provinces where they occurred, and thus they had difficulty remembering specific facts. However, when the researchers asked a set of why questions For example, why would Ontario have been the first place baseball was played? And those types of why questions, we actually call them these elaborative interrogation types of questions. The participants were forced to draw on their prior knowledge of Canadian history and relate it logically to the new information. So here we're getting a sense of what a strategy could be, having these follow-up questions of the why. I'm requesting that they elaborate more. And the last study I want to mention around support for helping students deepen connections is by Garfield and colleagues. And so they designed an instructional study in a college statistics course that focused on the concept of variability, which is a notoriously difficult concept to grasp for some. And so the instructors first collected baseline data on students' understanding of variability at the end of a traditionally taught course. The following semester, they redesigned the course so that students were asked to generate examples of activities in their own lives that had either high or low variability to represent them graphically and draw on them as they reasoned about various aspects of variability. So while both groups of students continued to struggle with the concept, post-test showed that students who had generated relevant prior knowledge outperformed students in the baseline class 2 to 1. Okay, so we've kind of laid the groundwork for the science or the research that's supporting why deepen connections. But now we're going to go a bit into what might be some methods that we can use to activate accurate prior knowledge. Okay. First off, we can use exercises to generate students' prior knowledge. So we actually just engaged in that a bit with looking at the rainbow at the very beginning of today's session. So that would be an example of opening the class with wonder, asking questions like, what do you notice about this image? What do you wonder about if you were to share an image on the screen? And so this strategy can actually help accomplish multiple objectives. Such an activity can activate students' prior knowledge, thereby helping them form connections with what they already know. And it also offers a wonderful opportunity for learning activities such as prediction and retrieval. Other examples of ways to generate students' prior knowledge might be asking them to create a concept map in which they have the concept or the idea that you want them to grapple with, and then are drawing lines and connecting it to other circles or concepts that come to mind when they think about the content in question. Or you can do a class brainstorming activity as well to kind of see what comes up for the students when they think about a particular idea or concept. And so what we know, or according to Ambrose and colleagues, using exercise to generate students' prior knowledge, they note that once students have activated relevant prior knowledge in their heads, they are likely to be able to integrate new knowledge more successfully. The next strategy I want to mention is explicitly linking new material to knowledge from previous courses. So that's pretty self-explanatory, particularly if you know the courses that your current course is building upon. And then we have the idea of following that same logic, but connecting the new materials to prior knowledge from your own course. And so instructors can help students activate relevant prior knowledge by framing particular lectures, discussions, or readings in relation to material learned previously in the quarter or the semester. Okay. I also want to note that the use of analogies and examples to connect to students' everyday knowledge. And so students can often show more sophisticated reasoning when working in familiar contexts, and we can build on their knowledge from these contexts as we explore new materials. And this is something that was also noted in Ambrose and colleagues' book on how learning works. So, as promised, we have some examples from Mike Horn, our University Teaching Award winner. And as we think, listening to Mike, also keep in mind, like, what might be methods that you could use in your class that could activate accurate prior knowledge. So, Mike, let's start with you.
Yeah, and I just want to echo a lot of what you're saying here that I do this frequently across all my classes, especially in the beginning of lectures. And it's just a good check to make sure that students are engaged and responding. The more I can get them talking early on, the better I can get a sense of their interest and participation and kind of reading the room. And yeah, I do this a lot in the computer science classes, even in large lecture classes. So this is an example of a kind of puzzle I will give at the beginning of a class where it's an invitation to make connections. So in this example, I'm asking students are learning how to program in the Python programming language, and I give them this example of um, music from an Adele song that's very repetitive. It's just these repeated arpeggios that go on and on and on through the song. So I play the music video and then ask them to kind of think about um, how they might revise or refactor this code to make it better. I'm very clear not to like tell them what I mean by better. That's part of what the elicitation there is to kind of give them a moment to reflect on all of the different things we've been talking about throughout the quarter and through their other computer science classes about what are sort of the aesthetic values of code that they're trying to produce and kind of thinking about things like elegance and reducing complexity and sort of reducing the use of magic numbers and those sorts of things. But it also allows them to bring in concepts that we've been learning throughout the quarter that they should be familiar with. So again, I want to give them space not to tell them what those things are, but to allow them to work together for, several minutes at the beginning of the lecture to kind of bring out all of those pieces themselves, and then we work through the example together. And I find this kind of elicitation activity to be good at getting, again, building that investment in what we're learning today and kind of pushing, connecting the stuff that we've been learning throughout the quarter to the new topics that we're going to be bringing in the next unit of material that we're working on.
Nice. Thanks for that example, Mike. And getting back to the question that I posed, so we've just heard about an example in a STEM or compute, specifically a computer science context. Is anyone are we able to think about how our particular instructional contexts or disciplinary backgrounds, how we might use some of these methods for activating accurate prior knowledge, or even if some of these methods feel familiar and that you're already doing them? Please feel free to note them in the chat or come off of mute. Nice. All right. And we're getting some endorsement of the book, How Learning Works, in the chat. Great. Awesome. So thank you for thinking with us around this topic of the method of how different methods to activate accurate prior knowledge. So we're going to continue to build off of this with the question, right, of what if the student's prior knowledge is inaccurate? What are we building on if what we are asking them to draw upon isn't completely correct? Um, what do we do then? It could all just fall apart, right? If we're making the assumption that they're accurate in in their prior knowledge. And so, again, Ambrose and colleagues, they talk about how research indicates that inaccurate prior knowledge, like flawed ideas, beliefs, models, or theories, can actually distort new knowledge by predisposing students to ignore, discount, or resist evidence that conflicts with what they believe to be true. So even providing a single correction or refutation is unlikely to be enough to help students revise deeply held misconceptions, but instead, guiding students through a process of conceptual change is likely to take time, patience, and creativity. So, what we can do is we can ask students to make and test predictions, noting that this is an effective way to correct inaccurate knowledge. So now we're going to delve into this idea of like how can we guide the students in the process of making and testing predictions. And of course, we're going to provide the science behind why that is an effective practice. Okay. So, um, in the same book, How Learning Works, they talk about the impact of asking students to make and test predictions. So they say being confronted with evidence that contradicts students' beliefs and expectations can actually help them see where their knowledge or beliefs are incorrect or inadequate while motivating them to seek knowledge that accounts for what they have seen. So I just think that that's a very powerful quote. I think that is something that we also see in our students of like, okay, there being a desire to kind of fill in this gap of knowledge when they see that there's a connection that they haven't quite made, and having that again be motivating to seek a better understanding. Okay, so now I want to talk to you all about a study that was actually featured in James Lang's book called Small Teaching, Everyday Lessons in the Science of Learning. So this study was conducted by Ogan, Levin, and Jones. And for this study, there were two French courses. And a part of the goal of these courses was to help students develop what the authors called intellectual competence. That is the ability to think and act in culturally appropriate ways. And so, with this course, they created, two experts created this computer assisted, this online tutoring program for the students. And this online tutoring program was based on the use of film clips. So, film clips in the context of this of these French courses. So here's the study. In the control condition of the experiment, students were shown film clips highlighting cultural attitudes or behaviors that are normally taught in introductory French classes. As the students watched the short film clips, they had the opportunity to take notes on what they saw. The students in the experimental group, by contrast, were given the opportunity to use the power of prediction to improve their learning. So their film clips would pause at key moments and ask them to make a prediction about what was about to unfold, and then require them to ponder what actually happened once the clip had finished. So the authors described their three-part sequence with the catchy phrase, calling it pause, predict, ponder. So they'd pause the video at certain points, ask them to predict what was going to happen next, and then once they continued showing the video, then the ponder part came in where they did a bit of a comparison around did what happened, did that align with their predictions, or what did it not, what might have been the reasons for that. So again, after they had watched the remainder of the clip, they had to answer a simple question about whether or not their predictions was correct, and then respond to the prompts to help them reflect on their prediction, such as, okay, well, if you were correct, did you see anything you didn't expect about the French culture? Or if you were not correct, what happened that you didn't predict? Okay, so what were the findings from this study of one condition of the students not using, just watching the film all the way through and taking notes, and then the other condition being the experimental one in which the researchers utilized the pause, predict, and ponder? Okay, so what they found was that the students who had the opportunity to make predictions outscored their peers in the first exam by about a 10% margin. Not only that, but the experimental group showed a better ability to maintain a productive discussion compared to the control group. Okay, so sit with that for a moment. And now we can even wonder, okay, why are predictions so impactful? What's behind this or making the predictions? Why is that? Why is that making a difference in the students' learning? Or why do predictions boost learning? All right. Of course, we have some answers for you. Well, first off, it's the idea that, neuroscientists are increasingly demonstrating that what is said on the screen, that our brains continuously create models of the world around us, and our brains use those models to predict how our experiences will unfold. And it also engages in corrective remodeling in light of what actually happens. So that's a bit of the science of why predictions works from the neuroscience standpoint. We also know that predictions reveal to students the gaps and problems in their existing knowledge or of the core subject matter, and then it provokes them to feel and repair their understanding. So that really goes back to the initial quote that we shared as we transitioned into why making and testing predictions is effective is because of this student desire to get a better sense of like how can I close this knowledge gap. And lastly, predictive activities give students a clear understanding of what and how they need to study and learn in any particular course. Yeah, so the idea of like even having so this could come in the form of giving your students pretest or well-planned pretest can actually serve as a predictive activity and alert the students to essential course content as well as the testing style of the instructor if you use the same structure of that pretest in the follow-up tests or the post-tests. So, all right. I think it's time to start getting a bit active or thinking about what might be the teaching activities that can really leverage predictions. Okay, so what do we know? And these activities are coming from insights from James Lang's book on small teaching, as well as an article from Gloria Gay entitled Preparing for Culturally Responsive Teaching. So the first activity that I want to highlight is you can give students a brief test on the material that is in a similar format to the final exam. That's especially helpful as I meant because, but as I said earlier, because they already have a sense of what the structure will be, as well as the type of content that the instructor cares about and believes that they should have a level of mastery of understanding by the end of the course. You can also pose questions to the students using classroom polling technology, but it's very important to have a bit of a pause before giving them the answer to that question or providing your explanation for what a particular answer is. And so what can happen during that pause? You can invite the students to paired or whole class discussions on their responses and then move on to your explanation. So that's a way of utilizing predictions. Another thing that you can do is think about how to bring in the pause, predict, or ponder when you are presenting cases, problems, or examples or histories to the students. And this is particularly important, especially when thinking about how we might be able to bring in more multicultural examples or cases into the classroom space. And so when we're thinking about presenting these types of cases and examples, it's important to note that these examples are used to demonstrate how information, principles, concepts, and skills operate in practice. And Geneva Gay, who coined the term culturally responsive pedagogy, calls them pedagogical bridges. Like, that's what she calls these cases and examples. They are pedagogical bridges that connect prior knowledge with new knowledge, the known with the unknown, and abstractions with lived realities. She also notes that teachers need to develop rich repertoires of multicultural instructional examples to use in teaching ethnically diverse students. And lastly, you can leverage predictions by closing the class and asking the students to predict what's going to be covered or what material will be covered in the next class. So again, these are just a few activities or strategies that you can use in your instructional context to leverage predictions, because we know that leveraging predictions is a way to correct inaccurate knowledge points. And I think we're ready for Mike.
Cool. Yeah. I'll just add in a few, observations that I've seen kind of observing different instructors in different courses around the university, but I've seen excellent uses of this kind of polling software. Different, there's a variety of different options, and the center has really excellent resources about how to use different kinds of software. So in large lectures, people using polling software that I've been so impressed by how it engages students. And even just that moment, we're going to take 1 minute to lock in our answers about what we think about is going to happen in this certain situation. Students lock in their answers, they get to see how each other voted, and then the instructor is able to show the the answer or run the simulation or whatever it is. But just as I'm watching students, I'm observing how much more focused in they are just through that simple act of like, we're going to take 1 minute to do a prediction at the beginning of the lecture. It's really effective. Um, in computer science, it's in some ways a little easy because we're generating code that actually runs. And so students can make predictions about what their code is going to do before they run it. And so we often are doing worked examples with students together in class, and we will frequently pause, ask students to kind of generate ideas about what's going on. This connects really well to other research on learning around the idea of preparation for future learning that kind of reinforces the same ideas that Veronica has been sharing. Um, I've seen really excellent examples in material science lectures where instructors are using simulations of different processes of materials, and those kinds of simulations give an excellent opportunity for students to make predictions before they run a simulation. Um, can you go to the next slide, Veronica?
Yes.
Thank you.
Oops, excuse me. Did I
Um,
go too fast? Let me go back.
and then
There we
I
go.
teach in some of my classes are CS education classes, so it's kind of like the intersection of computer science and thinking about learning and pedagogy. So this is a class I teach in with my co-instructor Paula Hooper. And Paula runs this brilliant activity where we have students playing with spirographs. And the point here is to try to get students into the habit of thinking, generating their own questions about rich phenomena, and then problem solving and trying to answer their own questions. And so it's a habit that a lot of our students aren't necessarily in the habit of doing. So in playing with this activity, we're asking students to write down questions they have, make predictions about what they think will happen in different configurations, and then there's all sorts of rich mathematics that this connects to. And so it's really kind of this role of getting them into the habit of like trying to reason with mathematical ideas to generate and respond to their own questions. So again, I see making predictions as this like very powerful set of activities that can be layered into many, many different kinds of classrooms, and really has an impact on student engagement and learning from my perspective.
Nice. Thanks, Mike. And so on this slide, we're posing a similar question, which was in your class, in your particular instructional or disciplinary context, how might you use these activities around leveraging predictions? So if you all want to come off of mute or engage in the chat again. I also wanted to lift up that Mike is not only a professor of computers and computer sciences, but also learning sciences. And I think that that is obviously just shining right on through with all of the examples that you're showcasing. So thanks, Mike. All right.
Hello.
Hi, Maurice.
Yes, I kind of have an example of kind of using prediction um, for testing prior knowledge as well as like correct prior knowledge and faulty prior knowledge, and also using it as motivation. Um, so once upon a time, I used to teach Arabic, and usually in the introductory class, the first day I would do a game. It's kind of like a guessing game. So I would um, uh, ask students to guess words that have cognates um, in Arabic and English. And so I would pronounce them in Arabic, and I would they would guess what the cognate is in English. And usually I would start off with some of the more easier ones, and then kind of let it get progressively more difficult. And I remember once a student got one of the most difficult ones, like the first try, and it was the cognate for a mattress. And when I asked her how did she know that, she said that she just happened to be of Italian background, and her last name meant mattress. And so, everyone that guessed correctly, they would walk away basically with a new word. And so, just kind of using that as motivation for them to keep studying and um, just kind of holding on to learning the language.
Wow, what a cool example, Maurice. And I even like how the asking of the question of like, how do you know? It allowed for a space for like storytelling, and we know that that's a way of better like connecting with people. And it happened to even tap into a bit of like the students like cultural background and knowledge sharing. So it's like we don't even know what will come when we ask the question of like the why, what brought you to that point. And a lot of times the insights that the students give us can be just so enriching and really kind of like liven up the class because of the new knowledge that we're getting or the rationales. And I also felt like a highly like embodied experience in terms of like learning through listening, which I'm imagining is probably major in language courses. But I think just like those multiple modes of gaining information or teaching information, I'm pretty sure is appreciated by the students.
Thank you. Yes.
Any other activities kind of coming to mind for you all about maybe something that you might want to try, or even something that feels familiar from your experience of being an instructor or being the student? Nice. Well, we're going to keep the conversations going. And as you can see, with each slide, we keep on building from where we previously were. Um, I wanted to provide a space to delve a little bit more into um, the types of examples that we may want to use to leverage or activate predictions. And so I want to refer back to Geneva Gay's concepts around culturally responsive teaching. I wanted to note that culturally responsive teaching uses heritages, experiences, and perspectives of different ethnic and racial groups to teach students who are members of these groups more effectively. And so here we talked about the importance of developing a rich repertoire of multicultural instructional examples, but now I really want to note that this is a learned skill, and I want to share some of the processes that developing this learned skill entails. So it entails understanding the role and prominence of examples in the instructional context. Um, it also then kind of, once you see the value of providing examples with as a form of instruction, then thinking about and appreciating and knowing the cultures and experiences of different ethnic groups, and then harvesting teaching examples from these critical sources. So that's a part of the process of, again, developing this a pool of multicultural instructional examples. And then the last aspect of the process that I want to mention is from there, once you have these examples, you're also learning how to apply these multicultural examples in the teaching of other knowledge and skills. So, for instance, using illustrations of ethnic architecture, fabric designs, and recipes in teaching geometric principles, mathematical operations, and propositional thought might be examples, intentionally culturally responsive examples to use. Or using various samples of ethnic literature and teaching the concept of genre and reading skills such as comprehension, inferential thinking, vocabulary building, and translation. So those are again some examples of how we might use culturally responsive examples within our instructional context. And again, this is informed by some material from Geneva Gay. All right. Mike, do you have examples of these types of considerations?
Sure, yeah, and I do want to like highlight here that I think it's important, as we think about culturally responsive pedagogy to approach it with caution. Like I think that the the most effective things we can do are to, center student voices in our instruction as much as possible and to make space for many ways of knowing and many ways of engagement. Um, when we do bring in examples, I think it's important to like sort of be humble about our limited perspective, our limited experiences, our limited viewpoints, and sort of acknowledging that we all come from a perspective, we all come from a culture. Um, and so like recognizing that in our instruction. I do bring in lots of examples. If you could go to the next slide. And in my computer science classes, I bring in a lot of examples of art and music and make connections to computer science. Some strategies that I use is whenever I bring in an example of an artist, so for example, Bad Bunny or Doja Cat, like I will go into a lot of depth about that artist in particular, focusing on their craft, the context in which that genre like emerged and how it relates, and then like focusing very specifically on like here's how like Bad Bunny constructs this song and produced this track. Here's the rhythm, the rhythmic structure, here's the chord structure, and then relating those things directly to computational concepts and ideas, of which there are always lots of relationships. So, as opposed to sort of saying, "Oh, I'm going to superficially splash Bad Bunny on the screen because Bad Bunny was in the Super Bowl halftime," it's about taking that artist seriously, and their work seriously, and demonstrating how it connects to all of these things that the students at Northwestern are learning now about computer science. And so when I'm thinking about culturally responsive pedagogy, that's kind of the position I'm taking on it. Yeah, this is that doesn't matter. This is kind of like what uh, some of the Bad Bunny instruction might look like, where we're sort of looking at computational structures like loops, procedures, functions, parameters as a way to sort of like dig into the ways in which, in this case, the rhythmic structure of different tracks is composed. Thanks.
Thank you. I'm just gonna look at the chat, see if we missed any pieces. Perfect. And yeah, and again, like I just want to co-sign everything that Mike was saying just around the importance of the humility in integrating um, uh, these more culturally informed examples as well. Wonderful. All right. Another consideration I want to bring in is the idea of bringing in the cultivating the growth mindset as you're thinking about examples or deepening these connections between prior knowledge and the new knowledge. And I think this is especially important because if you want to, especially if the student has some inaccurate previous or prior knowledge, we want to, how can we structure the class so that it's okay if because we're going to provide space and room to grow and evolve from where you have been. And so if you're not sure yet, the growth mindset encourages the development of intelligence in contrast to a fixed mindset, which considers intelligence to be fixed and unable to be changed. So a person with a growth mindset faces challenges in a positive way, resulting in progressive achievements. And there actually was an article in computer science classrooms about using the growth mindset. It came out in 2022, and I wanted to showcase some examples of what the instructors did to enhance growth mindset. But also, since this is the science of how students learn, we have to give you some research data behind it. So with this study, again, the context was in a computer science classroom, and the objective was to determine if faculty development in growth mindset and active use of growth mindset cues in these two computer science courses. They wanted to know if that would lead to improved academic outcomes after these instructors had undergone trainings around growth mindsets, and trying to see if there will be a difference or an improvement in the students as they went from the first level of this computer science class to the second level of the next class. And so what they found was that female students demonstrated the most growth as measured by academic grades in the first computer science class and maintained that growth in the second computer science class. The males demonstrated growth as well, with both males and females converging at the same high point of accomplishment at the end of the second course. They also noted that race and ethnic gaps between students were reduced, improving academic equity. But I'm sure like what the curiosity might be was how did the instructors signal growth mindset to the students? And so they did this in the form of providing specific feedback or messages during specific events, such as evaluation of assignments, quizzes, and exams. And here, this was a table from that article showing like what were some of the specific inspirational quotes that were used in the computer science labs and assignments. So they're all from fairly famous people. And I wanted to showcase a few of them. So here we have a quote from Winston Churchill saying, "Success is the ability to go from one failure to another with no loss of enthusiasm." Here's another one from Albert Einstein. A person who never made a mistake never tried anything new. And of course, we have to have a Michael Jordan one. We are in the Chicagoland area, right? So Michael Jordan said, if you quit once, it becomes a habit. Don't quit. Okay. So I thought that these were pretty interesting in noting that the different time points there, these types of messages were brought in, were in the forms of evaluations of assignments, quizzes, and exams. Uh, and Mike, can you share any ways that you've kind of brought in a growth mindset consideration into your classrooms when deepening connections?
Yeah, and I just wanted to add, like, I think that It's interesting. I think that growth mindset has kind of seeped into the popular consciousness, and our
Mm,
students are very much aware that they are supposed to have, not all of them, but many students are very much aware that they're supposed to have a growth mindset.
mhm.
Um, and the research is kind of backing that up, especially in the research since 2022 in CS education. And the distance between knowing that you're supposed to have a growth mindset and believing that it's real and it makes a difference is pretty substantial. So that students might know, okay, I'm supposed to have this mindset and sort of perseverance. But when they actually encounter challenging content in their STEM courses or other courses, it's very easy for that to kind of fall off and fall away. One thing we've been trying recently is using kind of submission exit tickets. So as they're submitting assignments, if you could go to the next slide, um, to create spaces for reflection on their experiences. So these are what we call emotion exit tickets, where when they submit an assignment, we're asking them to highlight all of the different kinds of emotions they felt during the assignment, and then to tell us a little bit about what they were feeling. And so we are kind of giving messages about growth mindset throughout our coursework and sort of reminding students that this is hard, it takes time, you've got to work at it, it's not going to be easy. Um, and then using opportunities for reflection that are kind of structurally built into the course to then go back and because like once you've just gone through an experience that may be difficult or frustrating, to like use that reflection moment to help them understand where they've been coming, how far they've made it throughout the quarter. So those are just some of the examples. We're really still working on this because I don't know that we know exactly how to do this best. And our interviews with students and the research that we're doing suggests that students still really, really struggle with this. So I'm curious to hear what other people have tried and whether or not you think it's working for you.
Thanks, Mike. And yeah, so we have our same question of, in your particular classes, how might you cultivate the growth mindset, or how are you cultivating the growth mindset? And even if you want to kind of I think Mike, you kind of pose like a bit of like the challenge between for students knowing that they should have this mindset, but then still kind of not having levels of doubt about if they can evolve in that kind of way. So this is a very open question that can be answered in whichever ways people would like.
Hi, this is EG. I've been able to do this in my electives. I still struggle to do this in my intro level classes, but for growth mindset in my electives, I try to do specification grading or ungrading and use revisions and reflections and take points away from the course as much as possible. I still struggle a little bit how to do this in intro class because I do want them to reach a level of mastery of the subject. But anyway, for this, what comes into my mind is I do specification grading and ungrading and with all revisions and all that, which creates a lot of grading work, which is the challenge. But that's what I do.
Mhm. Nice.
Thank
Thank
you
you
for
for
that,
that
EG.
example, Luigi. Mhm.
Yeah, I was going to say there are a few people in the also doing ungrading around, which is a really interesting approach that I think specifically designed to highlight growth over time for students.
Mhm. Oh, we have another comment in the chat. At the start of a class, students complete a discussion post on what they are looking to learn in the class. Then at the end of the class, students write a final discussion post on what they are taking away, their key learnings, what new practices they will begin to apply, and what else they want to learn about in the topic. Yeah, thank you for sharing that. It's making me think of some of the content from Mesmin Destin's talk from the featured presentation around having students envision their future selves and who they want to be at the end of the process. And so even some of the questions of asking them to think about what new practices they'll begin to apply, I feel kind of aligns with that. Oh, and we encourage students to reframe their challenges. Yeah, I like that. Sometimes I think of the reframing. Sometimes it could be like it's a challenge today. It's a challenge now. But like even just kind of bringing in that temporal distinction, I think is a way to help promote a sense of growth and the reframe as you were mentioning, Rebecca, in the chat. Nice. All right. Well, we are am I going backwards? Okay. So we're at the stage where we're going to give some concluding points. We will be having an exit poll, so don't leave just yet, as well as I'm having Mike and I are going to stay on for the remainder of the time and pose field questions. It could be a bit of like a office hour consultation space. So, in conclusion, students learn more readily when they can reconnect what they are learning to what they already know. Making and testing predictions can correct inaccurate knowledge. And lastly, conscientious examples and feedback can deepen connections between prior and current knowledge. Okay. So,
Great. Thank you so much, Veronica and Mike. So I'm going to share some things in the chat right now first. There we go. As a friendly reminder for what's coming up next in the program, the second synchronous online session on cultivating attention will take place live and online next Tuesday, April 14th at noon Central Time. This session will be facilitated by Laura Ferdinand and featuring University Teaching Award recipient and Searle Center Distinguished Fellow Benjamin Gorvine. And if you're interested in further thought partnership around applying concepts and strategies for your instructional context, please don't hesitate to schedule a 30-minute consultation with me this quarter. And so with these next couple or few minutes, please complete the anonymous and very brief Zoom poll to request your feedback on today's synchronous online session. I'll launch it now. There we go. And once you complete the poll, again, please feel free to stay until the half hour, which will actually not be recorded, to ask any burning questions on your mind with Veronica and Mike. You're also welcome to leave the Zoom room. I understand that we are at that sort of hour mark. Should you have another commitment to get to at this time? And thank you again, Veronica, for facilitating today, and Mike for joining us as our guest. And thank you to everyone for attending amidst your very busy and full schedules. And we hope to see you again next Tuesday. As always, if you have any questions about the University of Practicum, you can always email us at practicum@northwestern.edu. I'll go ahead and stop recording now.